You could still use Pascal's triangle, but you'd have to go to the 10th row of Pascal's triangle. Do you agree with me on that? Unless you just have a giant Pascal's triangle that you carry around with you, that's kind of a pain to write out Pascal's triangle to the 10th row if you really only need one number. Yes? So this is where the actual binomial theorem is useful. And the binomial theorem says if you have x plus y to the nth power, that the coefficients of the terms are n choose r combination x to the n minus r, y to the r. Which the exponent part, I feel like we can figure the exponent part out. We don't really need that formula. But this is really nice because you can do a combination to find that coefficient as opposed to going to the 10th row of Pascal's triangle. And so there's a few questions on your homework today that ask you for just a specific term. If you want to use Pascal's triangle, you can. But I want to show you that you can use this. And most of the time, they give you pretty high numbers. Like I think the first one on your homework is something like x plus y to the 14th power, because they're kind of wanting you to not use Pascal's triangle. So they give you pretty high numbers. On your test, am I opposed to you making a giant Pascal's triangle on the test? No. Am I going to let you come in ahead of time with a giant Pascal's triangle to use on the test? No. So, you have to kind of decide what you would rather do. The big question is, what is n and what is r? N is the easiest one. What is n in all these problems? The exponent here. So in this problem, n equals 9. And r is in lots of places, but r is the exponent on your y value. And if you think about this, we could work it all the way out. But if you think about, if we're talking about the 5th term, a lot of people want to tell me that r is 5. But on the first term, do you agree that it's like there's no y? It's like y to the 0. And so then if I kept going, you don't really have to write this out every time, but this would be like x to the 8th y plus x to the 7th y squared. On the 5th term, what's the exponent on y going to be? 4. It's always going to be one less than the term that you're on because it always starts with no y. So it's no y, 1y, 2y, 3y's, 4y's. So on this one, r happens to be 4. So n is the exponent on the outside, r is the exponent on y, which always happens to be one less than the term you're talking about. And if you know that, you don't need any of this. You don't need Pascal's triangle. All you need is this formula. N choose r, x to the n minus r, y to the r. And I'm just going to plug all that in. So I'm going to get 9 choose 4. X to the 9 minus 4 happens to be 5. And y to the r, which happens to be 4. Some people made connection in second hour that this was the 5th term, so x to the 5th. That's just a coincidence. That doesn't always happen. So don't think that that number and this number are always going to be the same. It just happened to be on this one. Like the next one doesn't work out like that. And you can just use your calculator for this. 9 choose 4. I think is 126. But don't forget, it's not just x and y, right? You have to plug in your x and your y up here. So x is 2x to the 5th, and y happens to just be 1 to the 4th, and you're just going to work all that out. I think on your homework, they actually give you the exponents, and they just want the coefficient, so it doesn't work out so bad. But I think this is 32, so 32 times 126, I got that to be 4,032. X to the 5th would be the 5th term in that. Again, I'm not opposed to Pascal's triangle on this, but I feel like this is where I'm like, okay, I have to use that combination if I'm just looking for one term, especially if I'm talking about like the 14th power. I don't want to make a Pascal's triangle that big. So let's do one more of these, and then I think I only have one other example. What do you think on that? All right, you're already sleeping. Like this, here, this counts as sleeping, whether you're all the way asleep or not. If you're like this for more than 3 seconds, that counts as sleep. Eyes open. Right. Again, notice 7th power, not impossible to do, but again, you have to write a little bit to get Pascal's triangle. What is N, what is R? That's what I want to know. N is 7. R is the term that y would be, which in this case would be, or the power that y would be, second, right? And if you know that, then you're just using the formula. 7, choose 2, x to the 7 minus 2, which happens to also be 5, y to the second. And again, you can always check. Those 2 should add up to that n, so that's a nice little check that you did that right. And again, I think if you just use your calculator, you get 21 there. X is x in this one, so I don't know why I put parentheses around that, but that's okay. And y is negative 10z. So negative 10 squared is 100. 100 times 21 is 2100. X to the 5th, z squared. On your homework, I think they word it a little bit different, and they say something like this. Like, what if they said, find the x to the 10th, y to the 3rd term for x plus y to the 13th? People kind of get weirded out by that because they're like, hey, that's not exactly how we did in our notes. I don't know what to do. I think this is an easier way, because looking at this, can you tell me what n and r are by just looking at this? What's n? N is your number on the outside, and what's r? The exponent on y. So you don't even have to think about what the exponent is. Like, they give it to you, which I feel like is an easier way. So just, I think on your homework, it's a couple of them are worded like that, and people get thrown by that a little bit. The only other thing that's on your homework today that's different than what you did yesterday, like some of it you're just expanding just like you did yesterday, but some of it they're going to give you a little bit more fun algebra to do. Like this. 5 minus the square root of 3 to the 4th power. And you're still going to do this. I'm going to use Pascal's triangle. Binomial theorem says you could go through and do a combination at every step, but I really feel Pascal's triangle, if you're expanding the whole thing, is a much faster way to do it. Remember that if you're doing the 4th power, you need the 5th row. Does everyone, did it make sense to everyone yesterday how we make Pascal's triangle? 4, 6, 4, 1. You could just go on forever. Pascal's triangle does a whole lot of things. One of them happens to be binomial expansion, but there's all this stuff if you look up Pascal's triangle of all the different things about Pascal's triangle. I always remember there's one more term. So if I'm at the 4th power, I need 5 terms, so that's why you need 5 of them. And remember that as it goes, x goes down, y goes up. So if I was writing this out, the first thing I would do is I would say I'm going to start with 1x to the 4th plus 4, x goes down, y goes up, plus 6, x goes down, y goes up, plus 4, x, y to the 3rd, and I'm going to end with 1, y to the 4th. Really quick check. All my exponents add up to n out there. All of them add up to 4. My coefficients are right, and now I just have to plug in my 5 and my negative square root of 3. Right? Like, that's the basic setup of what we did yesterday and what you're going to be doing on your homework today. The only difference now is instead of just having numbers and x's and y's, they're going to maybe give you some radicals, maybe give you some fractional exponents or negative exponents, where you just have to plug it in, and then the simplifying is the kind of the extra part. Someone in second hour had a question about this negative. If your second number is negative, you have to take that. So like on this one, x is 5. Y is not just square root of 3, it's negative square root of 3. So make sure when you're working that out, if you get a negative answer, it changes your sign. So I'm just going to go through and plug all this in, and then I'll work it out. So that would be 5 to the 3rd times negative square root of 3 plus 6 times 5 squared times negative square root of 3 squared. I better start writing smaller, this isn't going to fit. Plus 4 times 5 times negative square root of 3 to the third plus negative square root of 3 to the fourth. And the big thing I want to get across is I don't want decimals, but I want you to simplify what you can. So the ones with exponents, you just have to remember that when you multiply exponents, that you add them, and we have an exponent to an exponent, you multiply them. They're not that bad to do. But this one, you have to remember how to simplify a square root if it doesn't work out nicely. But 5 to the fourth, I think that's just 625, if I remember correctly. And this one, the only thing that this is going to do is I'm going to have to change that to a minus sign. But I can't do anything with the square root of 3, so I'm just going to leave that square root of 3 and multiply these numbers. So what is that? 125 times 4, which is, what is that? 500. Square root of 3, but it changed that to a minus sign. What about on this one? If I take the negative square root of 3 squared, what are you going to get? Negative 3? Just 3, right? Well, if you square something, the negative is going to go away. And doesn't a square and a square root cancel each other out? Or you could think that's the square root of 9, which is 3. Yes? So that's just 3. If you have a square root squared, it cancels out. So that's not an ugly number at all. That's just 25 times 6, which is 150, times 3, which is 450. Not my arithmetic skills. Now, unless you have one of those fancy calculators that many of you have, if you type in negative square root of 3 to the third power on most calculators, unless you have one that reduces and does those logarithms for you, it's going to give you a decimal. So you have to think about, take out the perfect square, right? What if you wrote that as negative square root of 3 squared with an extra negative square root of 3 left over? Do you agree that that's the same as negative square root of 3 to the third? This is still just 3 with an extra negative square root of 3. So this is the same as saying 4 times 5 times negative 3 square root of 3. And that would be 20 times negative 3 is negative 60 square root of 3. Notice the sign does change because the negative carries through. And I think if you typed in negative square root of 3 to the fourth on any calculator, it should give you the right answer because it works out to a nice number. But again, you shouldn't need a calculator on this because you should know if it's an even root, that's going to be just this twice, right? Which is just going to be 3 times 3, which I think is just 9. Which means, unlike all the ones we did yesterday, you actually have some like terms on this that you can put together. 1,075 plus 9 would be 1,084, I think. And then negative 500 minus 60 is minus 560 square root of 3. That's a little bit of work. That's still way less work than if you multiply this out 4 times, yes? Yes. So that's why we like the binomial theorem. That's why we like Pascal's triangle, is we could work stuff out, even though it's a little bit more work than what we'd like to do. It's less work than if you had to FOIL all that out and work all those terms out. Questions about that? Not the worst thing in the world, I think. Okay, I'm gonna skip this one. I'm gonna make you do that. This is 9-2 day 2, 4, 5, 6, 7, 8, 9. There are 9 problems. I know the first 2 are like what we did first, where you're just saying the exponent, like the coefficient, using binomial theorem. And then the other ones, some are multiple choice, some are just working out and expanding it. I'm going to pass your tests out, and then we're going to talk about them. So my advice is write this down, and then just let's talk about tests for a minute, and then you can decide if you want to work on test questions or work on this. But you have 30 minutes left, so